The purpose of this video is to help those of you who were absent when we went over the Abundance of Isotopes worksheet in class, or if you were busy taking your test during that time. So everyone should have had this available on Canvas prior to leaving, and it does a nice little job, this introductory part, of explaining what average atomic mass represents and some basics on how it's calculated. So we're going to just focus in on a handful of these problems. I've selected problem 1, 2, 5, and 7 as those tended to have more of the questions from class. So the first question, argon has 3 naturally occurring isotopes, argon-36, argon-38, and argon-40. Based on argon's reported atomic mass, which isotope do you think is the most abundant in nature? And then explain. So if we actually go to the sheet, you guys were given these prior to leaving, and we look for argon's actual mass, we see that the average, the average mass is 39.95 atomic mass units, which must mean that the isotope that is most abundant would be really, really close to that 39.95. So of the options that we currently have available, it should make sense that argon-40 would be our answer, as the percent abundance of that isotope must be pretty high to get the average to be weighted so strongly. Again, we use the example in class of if we look at your summative category versus your formative category. In college chem, it's an 85% summative, and so you could get an A on your test, a really high A, and then you could do poorly on your formative assessment, so maybe not turn in your homework, not do super hot on some of those quizzes, and then your grade will still be closer to the A that you got on your test than it would be to, maybe the D or C that you got on your formative. So this is very, very similar to that. For the next question that I selected, it's a very, very standard question. You'll actually see quite a few of these on your test. What I'm asking you to do on these is use all the information that's available to you given in the problem. At the end, we're going to round our answers to the hundredths place. And the reason we're doing that, again, is because in lab, our lab instruments, our electronic balances are actually limited to the hundredths place. We don't have an analytical balance at Esko High School that lets us go to the thousandths or the 10,000ths place. And so all of our units, all of our measurements, in this, in our homework, on our quizzes, on our summative assessments, will reflect to the hundredths place, and that's why we're going to round. Okay, so to set up this problem, it's actually really straightforward. So copper-63 is 69.17% abundant. So I'm going to start and write that as 0.6917 and has a mass of 62.9296. I'm actually going to keep all of those numbers as I'm writing this out because they gave it to me. Now, in my final answer, I will be rounding to the hundredths place, so I will adjust at the very end here. And then there's copper-65, which is 30.83% abundant, so 0.3083. And that average atomic mass is 64.9278. When I plugged that into my calculator, I got an answer of 63.5456 AMUs. So I will round that to 63.55 AMUs. You will be getting a copy of the answer key along with this assignment that you can look at before you actually do the quizzes. If after you take the quiz 1 time or 2 times you're still struggling on some of these, please do not hesitate to reach out via email at lzimney@esko.k12.mn.us to get some more personalized support. All right, moving on to question 5. This question had come up in class. So bromine has 2 naturally occurring isotopes, bromine 79, which has a mass of 78.918 AMUs and is 50.69% abundant. Using the atomic mass reported on the periodic table, determine the mass of bromine 81, the other isotope of bromine. Whenever it's asking you to determine something from the periodic table, please use the sheet that I gave you. I have posted a copy of this in Canvas as well. and you were all sent home with a copy of this. Now, if you were one of the unfortunate few who had to miss class this week and you did not get a copy of this last Friday, or you didn't get a copy of it this week, please download that onto your iPad and use it. This is what we need for the remainder of the year. So for the next 9 weeks, we'll be using this sheet. Anytime we use masses, we're pulling them off of this sheet and we are rounding according to the hundredths place. I will emphasize that over and over because it will be so important to you being successful on those quizzes online. Okay, so to set this one up, it's a little bit different. They're only giving us the atomic mass of bromine 79 and the percent abundance. But what's really nice, we're only dealing with 2 isotopes here. So we can actually subtract that 50.69% from bromine 81, or sorry, 50.69% from 100. And that's going to give us 49.31. And that's going to be the abundance of bromine 81. So 49.31% is how abundant that is, which eliminates a variable that we have to figure out at this point. So setting this up, we're going to set it up the exact same way that we did the other one. We'll do 0.5069 times 78.918 plus the percent of 81, which is 0.4931, times X, and that's going to equal the atomic mass of bromine, which I should have grabbed when I looked at it before. So the atomic mass of bromine looks to be 79.90. Sorry for all this back and forth. So 79.90. Now I'm just looking at a pretty straightforward algebraic equation where I'm going to solve for X. After doing that, I came up with an answer of 80.9276 as an answer. Again, we're going to just round that out to the hundredths place. So 80.93 AMUs should be our answer. That should be the atomic mass of bromine 81, which makes sense. If we were to round that, it would round to 81. Okay, last question. This one was a little bit more involved because it actually involves 2 unknowns. We do not know in question 7 the relative abundance of either isotope. So again, your math teachers helped you a ton in the past by teaching you some of these basic skills. Now chemistry is just going to reinforce that for you guys. So the mass of antimony 121 is 120.904. So I'm going to start by writing that. 120.904. I don't know what the abundance is, so I'm going to assign the abundance of antimony 121 as a variable of X. All right. I am putting that X after the number, and previous problems we were putting like the percent in front of the atomic mass. It really doesn't matter because you're just multiplying, so you should be good. Now we're going to add that to the mass of antimony 123, which is 122.904. And the abundance of the second isotope is actually going to be 1 minus X. Everything we've been doing up to this point has been putting the percentages as decimals. So we could think about this as 100 minus the percent, or we can think about it as 1 minus the decimal version of that. So that's what we'll do here. And it is important that it's 1 minus X and not X minus 1 because it won't math correctly otherwise. And then we need to know what the average atomic mass is for antimony. So we'll just do a really quick scan of that. And it looks like it is 121.8. So 121.8 AMUs. Now we're going to just do some quick little bit of algebra here to solve this out. Change up the color. So I have 122.904 minus 122.904x. Over here, I'll just rewrite this. Feel free to speed up the video at this point so you don't have to watch this process. You can just get to the answer. Okay, sorry. I'm going to subtract out the 122.904 from the 121.8. And that gives me a value of negative 1.104. And then if I take the 120.904 minus 122.904x, I get negative 2x. So that's math I can do without a calculator. Awesome. And then I'm going to go through and divide both sides by negative 2. And my value should be 1.104 divided by 2, 0.552. So 0.552. And then let's go back and look at what X actually meant again. We assigned X as the percent abundance of antimony 121. So SB 121 has an abundance of 55.20%. And then to calculate out the remainder, antimony 123, we're just subtracting that from 100, or we could subtract from 1. So that is going to be 44.80%. So just a really quick recap, a question like number 1, you should be able to easily answer just by comparing the different atomic masses to the average and look to see which one is closest to the average. That one will always be the most abundant. Whichever one is farthest from the average is typically the one that is least abundant. For question 2, you're going to see quite a few of those questions on your quiz, so just take them, multiply the abundance by the average mass, add those all together, and that should be giving you something fairly close to what you're seeing on the periodic table. A question like number 5, where you're solving for a mass, you have to know all the other information. So you have to know the average mass, the mass of the other isotope, and you need to know the percent abundances in order to calculate a single mass. And a question like number 7 would be what I would consider to be the more advanced problem. But once you've solved one of them, and then you solved another, and you solved another, you're solving them all the same, right? You're assigning one of the isotopes a value of X for the abundance, and then the other isotope is getting a 1 minus X, and that is the extent to which we'll be assessing on this concept. Good luck, and as always, if you have questions, please do not hesitate to reach out. If you're stuck on something, you've taken a quiz a couple times and need some additional guidance, please reach out and we can work through that online. Talk to you soon.